Last time we talked about variables and the keyword let, and now to understand this structure here that is inside this round brackets, inside parentheses, we need to talk about a very important concept in all programming languages, that is data types. In Rust, every value is of a certain data type that will tell Rust what kind of data is being specified so it knows how to work with that data. Keep in mind that Rust is a statically typed language, and that means that it must know the types of all variables at compile time. The compiler can try to infer what type we want to use based on the value, but there are cases that there are many types are possible, and it's very good practice to declare the type when we declare a variable. One example in such cases when there are many types possible is when we have this line of code here, so let guess. Here we define that the guess will be a type U32, and then we are binding these values here to guess, but these values here we are parsing a string, and if we don't add this U32 here, we will have an error because the compiler needs more information to know which type we want to use. In Rust, we will look at two different type subsets. One is called Scalar and one that is the compound. So a scalar type represents a single value, and compound types can group multiple values of other types into one type. So let's first look at scalar types. Rust has four primary scalar types. We have integers, we have floating point numbers, we have booleans, and we have characters. And these data types, they are very common in many other different programming languages. Let's take a look at integer types. Integer is a number without a fractional component. One example is the U32 type. This type declaration indicates that the value it's associated with should be an unsigned integer that takes up to 32 bits of space. And here we have a table showing different built-in integer types in Rust. So we have 8-bit signed and unsigned, 16-bit, 32-bit, 64-bit, 128-bit, and this arch. So for all of them we have signed and unsigned variants. Signed and unsigned refer to whether it's possible for the number to be negative. In other words, whether the number needs to have a sign with it or whether it will only ever be positive and can therefore be represented without a sign. Signed numbers, they are stored using choose complement representation, and I really encourage you to take a look at what is choose complement representation, and maybe in future we can also cover in a tutorial. Each signed variant can store numbers from -2 to the power of n-1 to 2 to the power of n-1 minus 1 inclusive, where n is the number of bits that this variant uses. So for example, if we take an integer with a signed 8-bit, so then we replace here to 8, the n is equals to 8, and then we can store 2 from -2 to the power of 7 until 2 to the power of 7 minus 1. And that means that goes from -128 to 127. If we don't use a signed variation but you use unsigned variation, we can store numbers from 0 to 2 to the power of n-1. So if we use a unsigned 8-bit, then we can go from 0 to 2 to the power of 8 minus 1. And that means that we can go from 0 to 255. If you feel that you want to take a look deeper into this kind of operations here, and in bits and binary numbers in general, I offer a binary numbers revision, part of this series Basics of Audio DSP and Machine Learning for Audio, and then I will cover binary representation, how to count in binary arithmetic, bitwise operations, converting from decimal to binary and vice versa, then some logic operations like OR, AND. We also talk about bit shifting, bit depth and powers of 2, and decomposing bit numbers in powers of 2. So you can find this in our playlist. It's Python for Beginners, Basics of Audio digital signal processing and machine learning for audio, and I'll leave the link in the description. Maybe it will appear somewhere in the screen right now. So going back to the data types, so we see that we have all these 8-bit, 16-bit until 120-bit, but we have this I size and U size from this arch, and that depends on the architecture of the computer your program is running on, and this is denoted as arch. So if your architecture is a 64-bit, this arch will be 64 bits. If your architecture is 32 bits, you'll be on 32 bits. We can write integer in different forms that are shown in this other table here, and we can also use a visual separator to make numbers easier to read. For example, we can use 1 and then underscore and then 3 zeros, and these will have the same value as 1000. And what are these other forms that we can write integers? We can use decimal, hexadecimal, octal, binary, and byte. And byte are unsigned 8 only. Rust will default to type integer 32 for integers. One very important thing to understand when we are talking about integers and data types is what is called, for example, the integer overflow. So if you define a variable that's of type unsigned 8, that means that it can hold values between 0 and 255. But if you try to change this variable to add a value that is outside of this range, for example, if you want to assign a value of 256, but you define as a unsigned 8 bits, there will be an integer overflow. And if an integer overflow happens, there are two things that can happen. If you're compiling in debug mode, Rust will include checks for integer overflow that can cause your program to panic at runtime if this behavior occurs. If you are compiling in release mode with the release flag, Rust does not include checks for integer overflow that can cause panics. And if the overflow occurs, Rust performs the two complement wrapping. So in short, values greater than the maximum value of that the type can hold wrap around to the minimum of the values to the type can hold. So in this case, if we're using an unsigned 8 bits, the value 256 will become 0, the value 257 becomes 1, and so on. The program won't panic, but the variable will have a value that probably isn't what you are expecting. Another scalar data type in Rust is floating point types. And Rust has also two primitive types for floating point numbers, which are numbers with decimal points. So we have Rust floating point types that are F32 and F64, which are 32 bits and 64 bits in size respectively. The default type is float64, because on modern CPUs it's roughly the same speed as floating 32, but it is capable of more precision. And all floating point types, they are signed. So here we are not defining the type when we declare this variable, so it gets the default, which is a floating 64. But here we don't want to use the floating 64, we want to use the float 32, so we are declaring the data type here together with the variable name. Another type is the Boolean type, and as in most other programming languages, Booleans they have two possible values that can be true or false. And Booleans, they are 1 byte in size. And the Boolean type in Rust is specified by using this keyword bool. So here we are defining, for example, that a variable t to be equals to true. The compiler will infer that the type of this value is a Boolean, but here we are declaring the data type together with the variable name. So this is the explicit type notation when we declare variables. And we use a lot booleans in conditionals, for example, such as in an if. So if that is true, do this. If that is false, do that. That we are going to take a look in future when it appears in our examples, or when we decide is a convenient time to take a look at them. We have one more scalar type, and this is the character type. So the character type is Rust's most primitive alphabetic type. And here we have some examples. Here we are defining a character variable, and we are binding the value z to this character. Here we are not declaring the type. Here we are doing the explicit type notation, and we use the single quotes to specify character types, and that is opposed to string literals that we would use double quotes. So Rust's character type is 4 bytes in size and represents an Unicode scalar value. So we can represent accented letters, Chinese, Japanese, Korean characters, zero width spaces. They are all valid character types in Rust. We will take a closer look into these types when we use them, but now we've seen all the scalar types, so let's move to the compound types. And as we've said before, compound types, they can group multiple values in one type.